Let's do some examples of how to calculate the moment on a member. I have a 100-pound force being applied at A. £200 applied at point E. 300 pounds applied at D, and I also have points labeled B and C. One of the critical components now, up until now, the dimensions haven't mattered that much, but now that we're applying forces at different locations, it's critical, absolutely critical, to include dimensions on your free body diagram. So A is 10 inches up from BCDE. Then BC is 8 inches. C to D is 6 inches. And then D to E is also 6 inches. So I need to find the moment of the force at A about point E, the moment of the force at E about point A, and the moment of the force at D about B. This is already my free body diagram. So for A, I need to find the moment about E, and the subscript that you use is the point about which you are taking the moment. So the moment about E is equal to the magnitude of the force at A times the perpendicular distance D between E and A. My force, and this is going to be the magnitude of my moment, the magnitude of the force at A is 100 pounds, and the perpendicular distance between E and A is this distance here, which is 10 inches. So my answer is 1,000 pound-inches. But make sure that you include which direction that is going. So if you look at it and you were to put your finger on point E and apply the load at A, it's going to create a counterclockwise rotation. So you just draw an arrow in that direction to show that that's the way it's going to spin. Then B, the moment created by the load at E about A. So we have the moment about A, subscript A, is equal to the magnitude of the load at E times the distance, the perpendicular distance between A and E. And the reason I do this here, this is my point of application and this is my load, which is going to be different than here. This is my point and this is my load. So my force at E is 200 pounds, and the perpendicular distance that's between A and E is going to be this distance, You can either look at it as that one or look at it here. Either way, it's the same distance. And that's going to be 12 inches. So my moment is 2,400 pound-inches. And again, put your finger on the point of application, or the point about which you're taking your moment, and push the member like you would if that load was being applied. So push it in E and see which direction it's going to go around that point. You're going to have a counterclockwise rotation. And the last one, the moment about B is equal to the force being applied. The moment about B, and it's asking for the force at D. So I'm looking at the force at D, and the perpendicular distance between my point of application and my force is equal to 300 pounds. And my perpendicular distance between these two, so here's B, which is my point, and now my force is being applied here, so my perpendicular distance between these two is this distance, which is 8 plus 6, so 14 inches. So my moment is 4,200 pound-inches. And once again, if I put my finger at B and apply the load, let's try this. Put my finger at B and apply the load at D. You can see which way the member is going to spin. So it's going to be in the clockwise rotation this time. Make sure I double underline my answers. And that is how you calculate the moment.